Okay, sorry about that. Had unexpected guests. I'm gonna have to get an away screen here one of these days. Anyhow, back to what I was saying. What are we doing here? Hold on, let me reload YouTube. There we go. Okay, anyhow, as I was saying, this is my thread checking tools. They're pretty nice because especially when you're not trying to get anything real accurate. So this is M10 by 1.5. I can just thread this in here and say, yep, that's it. That's an M10 by 1.5. So now I know that I'm going to need to make an M10 thread on the end of this thing. So let's see if you can see any of that. Okay. It's pretty washed out, but maybe it'll come up whenever I'm doing. So, I guess first things first, I'm gonna just gonna make this a profile. And we're gonna do the whole profile in one go. So the whole thing from, let's see, I'm gonna be working from this end up, over, down. And the only thing I'm not gonna do is cut it off. Cut it off and knurl it. This is actually big enough that I might be able to knurl it at work tomorrow with the other kind of knurling tool, because it's a coarser knurl. So first things first, we'll just make this profile real quick and get it going. So what's our overall length? That's the first thing we're going to want to know. .275. Okay. That's just so I have an idea in my head of what I want to do here. So first thing, I want my X to be 10 millimeters, and 10 millimeters is 392. All right. Let's go grab the calculator here, and we'll just convert these things, because using the dimensions that you get from the caliper aren't always accurate, because there could be wear on the part whenever it's raw like this and not freshly machined or anything. You don't know what the tolerances are supposed to be, but I do know that's supposed to be 10 millimeters, so I should get or that's theoretically supposed to be 10 millimeters, so what I should do is I should get the calculator and tell me exactly what 10 millimeters is supposed to be. So, be right back. Okay, so 10 millimeter convert inch, so 393.7. So we'll make this 0.3935. Want that to be a little bit lower. We'll start at 0, no radius. Then our next place is going to be next point is back 1.1 minus 1.1. 3 is going to be what we want our diameter to be. I'm going to make it 625. Actually, I'm measuring 646 or 650, depending on where I grab it on the knurl. So I'm not sure how much the knurl is going to expand that diameter. So I'm just going to call it 635 to 20 thousandths. That seems reasonable. 635. And then how far back do we go? I'm going to start the taper at 2.875. Minus 2.875. And then I'm going to make the taper here, and the taper is, again, this is just an eyeball kind of job here. There's no drawing or anything. So we'll just go to the end. 425 diameter. And at our final length of 3.278. And then I'm going to want to, that's exactly the end of the part. So what I actually want to do is leave a little bit of a landing so that whenever I go to cut this off, I have a flat spot and no ledge for the cutoff tool to fall off of it and change the length. So I'm going to give this another 1/8 of an inch, so minus 3.375, minus 3.375, and I give that a little bit more, 3.4. And then the last thing I want to do is I want to make sure this cuts back up out of the stock. My stock is 3/4 of an inch, I'm pretty sure. Yep. So 0.750. So my stock diameter is 0.750. I want my Z clearance to be this, my stock to be that. Tool clear diameter, I'll just make it 0.875. Stock Z, we don't have any on stock Z. And this, what are we going to call this? We're going to call this NUR, neural pin, 10 mm. And we're going to post this to a file. And this is stuff that I'm working on for Universal Tool. And save. So there we go. There's my profile right there. So we want to add a couple more things to this. So what I normally like to do is do a conversational edit. And you're going to insert a step, cancel. And I want to face this off, and my initial is going to be 0.750, 0 start. I want to start, yeah, 50 thousandths, that's fine. And then face, and we want to move that up. So that's going to be the first thing we do. We'll face, then we'll cut the pin profile, then we will insert step, thread, tool 3, Alright, so now we have to make some crap up here. So how long are our threads, first of all? They are about 650. So minus 0.650. Start at 50 thousandths above. And we want our pitch to be 1.5 millimeters. Convert to inch. So that's 0.0590. So 0.0590. And I don't have so what was our 10 millimeter convert to inch 0.3935. So what's our minor diameter of a 10 millimeter thread? That is the question, which I do not know offhand. So let us see if we can find out. Screen capture. So we need to know 10 mm thread, 10 millimeter thread dimensions. Let's see if this guy has it. So what we're looking for in this particular case is the minor diameter. So this looks like this is probably the right. So ISO size is 10 M. Pitch is 1.5. Pitch diameter. So minor diameter male thread. So that's what we're making. That's what we. So it's 8.16 millimeters. So we get out the handy calculator, and we go 8.16 millimeters to convert inches. That's 321. Let me double check that. 8.16 convert inch. Nope, screwed that up. 8.16 millimeters convert inch. So 321.25. So we're just going to call it 321. So here we go. Where are we going? Whoop, wrong mouse. So 0.321. Lead length, that's fine. Depth of cut, 0.010, that's fine. I'm going to slow down our spindle to about 500 RPM. Just because this is a pretty coarse pitch, so if you go too fast, you can actually go faster than the carriage can move. You don't want to do that. So 650 start and so we're going to call this an M10 1.5, and we'll insert this. So we'll face, we'll make the profile, then we'll thread, and then we'll insert one more step, and we'll put a chamfer on there, an OD chamfer, starting at 10 millimeter inch, 0.3935. Right, we'll make a 45-degree chamfer. Our start will be at 0. Our end will be, this is the size of our chamfer, yeah, 20 thousandths. That's wonderful. And we'll insert that. So we'll save this, close. So that is looking like a thing. So now we're going to be using tool 5 for this whole thing, which is a pointier tool so that it can get down into this angle. Hopefully you can see that there. So let's pull up tool 5. And then I can, you know what, let's see about getting our work camera set up. Let's see what this looks like. Alright, so let's see if this works. So, project. That looks like poop. Okay. So, we kind of need to come out here. Something like that'll work. Kind of the wrong orientation for you guys, but gotta work with what we're given for right now. How's that look? That looks pretty good if it stays put, huh? And I'll be able to close the lid if I need to. Okay, let me see if I can get a spring clamp and hold that on there. I'm going to trip on this sucker sure as shit. How's that look? That looks pretty good. Let's see what closing this looks like. Not particularly great. Okay. So now all I have to do is set my 0 for my X, or for my Z. I can just bring this down. Okay, I don't want to be any closer to the jaw than that. Let's see, can you even see? So there's the cutting tool down here. This ain't even what I'm using. But such is life. Okay. The whole thing seems to be hazy. Is this? I got a big fat fingerprint on there. Probably. Don't trip. Don't trip. Okay. Maybe it's just the ambient light from the light bulb. The light bulb is like right next to that camera. I don't really like it, but there's really nothing I can do about it at the moment. Make it better next time, right? We're okay for now. So that's where I want the back of my tool to stop. So if I go into the Z position and tell this it is at minus Z 3.4, minus 3.4. Now when I go to 0, that'll be the front of the part. And I can just put the tool in and touch off that way. So. Throw this part in here. Left my keys over at the other machine. Okay. Now I should go to Z0. Actually, just a little bit above that. About 30 thousandths. Go X down a little bit. Now I can just pull the material out until it touches that tool tip. And now it is set. And let us try the coolant. This, I know this isn't going to work. Hey, coolant's working. Okay. Let me do something else real quick before we actually get into cutting anything. Let me clean off that glass real quick. And, okay. So I will set my G30 right there. Let me clean off the glass real quick so I can close the window. And hopefully you can still see what's going on down there. Yeah, because what I'm going to do is, when the coolant starts, when the machine starts going, the coolant's going to start spinning off of the chuck and everything and get everywhere. So you're going to have to, you have to keep this door closed and just use this plexiglass panel to see what the heck is going on. Which is really bad for glare, but really good for keeping crap off the floor, you know. So if it's between glare, a visible glare, and swimming in this coolant, you guys are going to have to take the hit with the glare. You know what I mean? like now. You'll be able to see what's going on in there, okay. Okay, so I got everything stopped. Just move up here, set my G30 again. Just okay, I think that ought to do it. So we're going to cycle start. Whoa, 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 whoa. Main. Stop. Set file. Oh, okay. It wants to face with tool 1. Face with tool 1. Tool 5. Tool 3. And then what tool are you? Tool 1 again. Okay. Now I know what it's doing. Close. Main. Clear messages, main. You'll have to excuse me whenever you first run a part like this. It can be kind of nerve-wracking. If you don't want to do anything and have it just crash. Okay, so that was good. So now we're going to do the external profiling. That's what I was kind of figuring was going to happen. Whenever it got near that chuck of the pool, it was going to splash up on there. So that kind of sucks. That's what we call chatter, that noise. And what it ends up doing is leaving a really bad finish on the part here. You might be able to see it. But I'm going to just double check the dimension on it. Because it looks like it's, I mean, in this area it doesn't matter if it's chatter because we're going to knurl it anyhow. On this area where the threads are, if the thread dimension is okay at 10 millimeter, so that's half a millimeter too big. So that's not good. So we could just pull that down though. Let's see, what do we got? What do we want to be here? 630, right? $650. Okay, so that makes sense. So the whole thing needs to come in a little bit. Uh, 10. It's got to come in 21.9 millimeters, or thousandths. So if we just go over to here, go to table offsets, go to 5, we have our X wear at plus 45. Okay. So it should be 23. 023. That should bring us right in line. And so main. Now we know that we get this chatter here, but usually that we could help fix that by slowing down the RPM of the cut. So if we go to File and do our conversational edit, and we edit this, so we don't want our finishing SFM to be 320. We want it to be probably about half of that. So we're going to say about 175. 3,000s finishing. Okay. Works for me. And then we'll save, close, and it looks like I keep getting an error because this thing's trying to move back too far. And the reason I got it moving back so far is because I got this drill in the it's because I got this drill here in the in the turrets. So I'm just going to take that drill out. And we'll put this away. This is a 6mm drill. And now I can move my touch off point and my tool change position a lot closer, so I can set my G30 here. Alright, so now we're just going to run that again with a different offset on there. And you know what? I haven't seen if anybody's even watching. Did I mention what I'm making today? Not really. So I don't even know what it is. It is a something. Some kind of pin here for something. Some customer came in and said, make me 2 of these. So that's what we're doing. Alright. Anyhow, back to what we're doing. So we're just going to start right from the beginning again. Shouldn't touch anything. Okay, that's giving me my optional stop. Let's go again. Let's see if I can do something about this light coming in here. Yeah, that's a little bit better. Hang the old apron up in front of the only friggin' light source I got. But that'll work. That's a little bit better. Kind of worried about that back drag, but I know it's going to get taken away here momentarily. That might have just been too much chatter to get rid of. So what I did to try to get rid of it though, I turned way back on the RPM and I increased the feed to try to get it to get a little bit more pressure on the tool so that it would quit chattering, but evidently it ain't going to do that. So we're probably going to have to fix it the old-fashioned way. The old-fashioned way being I'll have to get out my file, just file that down a little bit. Like I said before, we're just going to knurl that and thread the end of it. So all it has to do is look nice, and I'm just going to thread it until the nut goes on. So let's see what it does for the threading cycle. Sounds like it's got a little bit of chatter in it, but not too much. Looks like it's getting down to full depth there. Finally, right? Okay. If I was making a bunch of these, that's definitely a place where I would try to increase the cycle time. But for the two that I'm making, that's fine. Okay, so let's see what we got. And the real test, does the nut go on? No, the nut doesn't go on. Okay, we're just gonna, you can't take this out. The trick whenever you're doing these threads like this is do not take them out until they're actually done. So right now I can still fix these threads because I haven't taken it out of the chuck yet. So what I'm going to do is I'm just going to bring it down a couple thousandths and test fit it on until it goes. So let's see, we go back into our offsets. That is tool number 1, 2, 3. Tool number 3. Tool number 3 has an 001 positive offset. So let's make that a 003 minus 3,000. So that's a 4 thousandths. difference. And what we can do here, this is kind of nice, is all I need to do is the M10 thread. So I'm just going to move this up in the program and save it. That way I don't have to worry about waiting through all the rest of that stuff. I can just... Now that's not a good program for the next one. I'll have to go back and change that again. But for this one here, I can just do that and try again. And while we're at it, since we don't really want to wait all friggin' day for this, let us conversational edit 0.018. So, see. Okay, so there it says number of passes. It's telling me at 10 thousandths depth of cut, it's going to take like 53 passes, which is why it took so long. So at 20 depth of cut, we're only going to take 14 passes. That is much better. So we'll finish editing, save, close, reload, main, and cycle start. Test that. Okay, so that nut is going on, but it's got no play. Now you would think that's a good thing, but actually in production it's really not. Because if there's no play, that means that the next nut, if the nut is smaller, it might not actually go on. So I'm going to bring this down a little bit more, like a tenth or like 5/10 more. So minus 0.0035. And we'll run that again. Okay, again, we'll check our nut. Oh, that's going on like butter. Now, if I really wanted to be perfectly correct on this, what I should do is get out the 3-wire gauges and measure this and check the pitch diameter and check that against the tolerance, but for something like this, that's close enough. So the next thing I'm going to want to do is knurl this thing, but I usually do fine knurls here, which are not quite as coarse as the one that we're trying to get on this thing. So this is a lot more coarse of a knurl. Let's see if you can see it. Does it want to do it? There it is. No, no, yes. I am not good at this. Okay, catch it out here. And then... Well, anyhow, you're just going to have to trust me. That's a much coarser knurl than I can do here. So, I'm going to do a little trick. I'm going to leave this on the stock, leave this part on the stock. But what I'll do is I'll just flip it over and turn another one on the other side, because that would make my two that I need, one on each side. And then when I get to work tomorrow, where we have more coarse knurling tools, there's a tongue twister. Anyhow, yeah, so when I get there tomorrow, I can knurl that on both ends of the stock, and then just part them off and they're done. So let's do that right now. So give this a stop. And give it a Z. And give this a flip. So there's our part, just stuck on the end of this thing here, waiting to get knurled. Yep, that looks pretty good. Let me just double check it again. I guess there's really no point now because it's out of the lathe. It'd be really hard to catch that thread again. Nope, that goes right into the my thread checker. So I'm going to call that a happy thread. And for as bad as the chatter sounded, it doesn't look too bad. Okay, so we want T1, right? And we will go to myself about 30 thou. Touch it off. There we go. And now we're going to have to go into File and Conversational Edit. And remember, we got to move this this knurl, or this thread, back down into position. So we'll move this down. After that, front chamfer, save. Or else it would try to thread it immediately, and that's not what we want it to do. So, I'm going to turn down my RPM 50% for the next external profiling. I guess you might want to see what's going on down there. I'm also thinking that insert may have seen better days. that's not chattering as much as the first run was. Yeah, I really don't like that back cut. Okay, so what's going on here? Okay, it's about the same as before. Although, got a little bit of a ledge there. Let me rerun this thing from the beginning without moving nothing. Okay. Sweet. So I thought that might have been the case. So what happened here is, let's see if I can just move you over. There we go. This is pretty hard steel, and it actually pulled out of the chuck just a little bit, and you can see that there's a lip here where it's kind of knurled up, you know, and screwed up. So this isn't the right length. And when the tool came down to face it off again to get it back to the right length, it took too much of a bite and tried to walk up onto the tool. And that consequently snapped the back end of it off. Now, this sounds like this is a real failure, but I can still save this part. All I have to do is put this back in the lathe, face this end off until it's the right length, and then it actually broke off back here past the taper. So I could face this back end off and get rid of this jagged edge, and it'll be like it never happened. But that is definitely something I'd want to do in the manual lathe. Just because now that we know that this material is brittle like this, we don't really want to get too aggressive on trying to do things with the CNC, because you could crack the tool again, which I'm sure that insert is cracked. As a matter of fact, I should probably just take it out and replace it. Now, as for the knurling on this end, it won't be as easy tomorrow, but what I'll be able to do is grab on this threaded end and put the knurl on it that way, and hopefully that'll work. I'll have to grab it with a collet rather than a 3-jaw chuck, but that so that I don't distort the threads when I grab it. But that should be fine. I can do that. So let's see. First things first. Let's get the rest of this out of here. Set that over there. And let's see. This is going to be too big for a collet, isn't it? Let me go check something real quick. Yep. So that's in between a collet size. So I'm going to have to take the chuck out of this machine, put it in the manual machine, and then do what I was talking about. So let me go get the other chuck key, pull this thing out. So this. Okay. Now I'm going to have to bring you all for a ride again back over to the manual lathe. Oops. Just onto this one so we don't give anybody motion sickness or something. Right there. And for now, don't want to grab that all over the wire. Now, move you all back over here. doing one spin around so the cord's on the right side. Whoops. Okay, get the project cam back up on this project stand. Oops. Alright, let's see what that looks like, right? Well, that's pretty not bad. Okay, let's move you a little bit up this way. There you go. Okay, so what I got to do now is take this off. Where'd my chuck key go? This will work. Let me get this other collet out first. There we go. That's right, this one's a little bit different than the other one. Oh, here it is. And neutral. There it is. Just do a quick wipe out of this socket. Align my dots. And one last thing. There we go. Okay. Now, we can just throw this right in here. And here, like so. Take our knurling tool, our fine knurling tool, and get it out of here. Put our regular old number 4 in here. Now to find the appropriate length on this, the easiest thing to do is, I have this shoulder that I know I want to be is in the right place right now. So if I just touch off this shoulder and call this Z0. Now I can come out here measure the original again because I don't remember what it was. 1.1. Okay. So when my DRO reads 1.1, I'm golden again. So I'm just double checking now that I am at 10 millimeters, because evidently there's something wrong with that cutter over there. So I am at 10.19. So I can adjust that on here. 10.19. And now I will just finish this diameter down to 10 millimeter. So there we go. That's pretty much fixed. Put the quick chamfer on it. Now I might consider just doing the threads here manually, but I would have to do a change gear to get it to do a metric thread. Let me see if I have a die. Nope, no die. So I don't have a die to cut these threads, so I'm going to have to put this back in the CNC to cut the threads on this, because that is actually faster than trying to change the gears on the back of this machine. So let me finish this back end first. So this is the end that snapped off. Let's see if it'll focus. Of course it won't. It wants to. I'm gonna figure out how the damn thing works here one of these days. But you can see it just snapped off nice and clean. And what you might not be able to see, but I could see it here, is that it snapped off after the taper in that flat spot that I left for cutting off. So that means I'm going to be able to just face this thing down like I did the other side until I get to the taper and be good to go again. Let me just double check this with the overall length. That's looking pretty good. Just zero that. 13 thousandths more. So there we go, that's perfect. Now, that's all well and good. Now I got to put this thing back on the other machine. I wish I had another chuck to do this with, or it's fitting to call it, but that is not in the cards. I'm just glad this is a D14 chuck. Where's my other chuck key? There it is. It's going to be too hard to put you back up on there to see the threading. So what I'm going to do is I'm just going to disconnect the project camera, leave it sit over here, and I'll just bring you back over on face cam. So just coil this guy up. Okay, now back over again. Okay, I guess I have to give you a spin. Spin around to get the wire on the right side. There you go. There's the 360 tour. All right. Just wipe this socket off real quick. Get the points lined up. Chuck the key in my hand. And one more. There we go. I'm debating to myself here whether I should take that insert out or not. I think it's going to be okay. We're not going to actually be using it. So, now we just got to go back into the file, do our conversational edit, and move our M10 up to the beginning. Save it. Now, all we got to do is, since everything was programmed from the front, we just have to show it where the front is. We do that by going down to about there, coming over to here. Okay. Now, just clamp this down. Like we did before, but we're at 0 rather than at a positive number. And we can just call this 0. Now we can move this back, close this up, and cycle start, I believe. But you know what I am going to do? I'm concerned that the wear that I put into that tool, the cutting tool, the threading tool in particular, was probably due to was probably needed due to the deflection of the part because it was sticking so far out, which is the same reason we kept getting that chatter. So I'm just going to bring the offset back down to 0, and I'll just run it again at 0, and I'll check it again. So I already did that, so let's go. I know you guys can't see it, but you might be able to hear that it's cutting a lot smoother. It's not getting any of that whining chatter. So we'll just stop this right there, check our nut. As I suspected, if I had left that 3,000 in there, this nut would be too loose. So it's a little bit tight right now. So we'll just go back into the offsets, bring it down maybe minus 0.0005. There we go. Anybody watching? Don't look like it. Okay. So we'll just cycle start again. It sounds like it's touching just a little bit, so that might be a little bit of bounce. Okay. Check that nut again. That's on the tighter side of what I might really want for a nut, but it's good. So there we go. That's how you break a part and then fix a part. So that part is still good. It's just got to get knurled. And again, we'll do that at work tomorrow. I just have to remember to bring my 10mm collet because we don't have metric collets at work. Just double checking. Yeah, that's a tight fit. That'll work good. And been working down here for about an hour and a half, probably 2 hours. I think that's going to be enough for one day. I had plans on doing some making some call it extender stops, but that ain't in the cards for tonight. Maybe we'll try again tomorrow if I don't have to bring work home again with me. So, all right, guys. I hope you enjoyed the stream. If anybody watched it, so I'll see you in the next one. All right. Bye. Maybe not. Are we still streaming?